2 to 0. So if you can see, this angle is between negative pi over 2 and 0. If pi over 2 is straight up, then negative pi over 2 will be straight down. So if I look here, we'd have negative pi over 2 would be right here. And it says it goes from negative pi over 2 to 0, so it's somewhere in quadrant 4. So that's all this is saying look in quadrant 4. Well, in quadrant 4, we have all students take calculus, cosine's positive, secant's positive, but everything else is negative. That's all it's saying. So when we get done, those should be positive, everything else should be negative. Well, they give me a tangent alpha equals negative 7 over 4. What you should probably do right away and just say, oh, you know what? Cotangent equals negative 4 over 7. You just flip it. Easy peasy there. Now, on these problems, to go from one trig to another, basic, because this is just tangent equals. We're going to talk about other ones in the future, but this is just tangent equals a number. Well, if I need to get from tangent to anything else, we're going to use our a squared plus b squared equals c squared, or one of our Pythagorean identities. So then I just go in my knowledge bank and go, you know what? 1 plus tangent squared alpha equals tangent squared. Does that go with cotangent, or does that go with secant? It goes with secant because cotangent, I'm sorry, it should be cosec. Cotangent goes with cosecant. Tangent goes with secant squared. And now we just take this negative 7 over 4. Do not just replace alpha with this. Replace all of this minus the squared. The squared is going to remain there. So that means I'm going to have 1 plus negative 7 over 4 squared equals secant squared.
Wait, I'm confused when we flipped it back again.
Why did I flip it back?
Negative 7 over 4.
Instead of using the negative 4 over 7?
Yeah.
Well, notice this is 1 plus tangent squared. Well, you could have. Now, this will get me secant. Okay. Secant will get me cosine because I'll flip it at the end. Okay. So I'm going to work through this, and I'm going to get secant equals some number. I'm going to flip it, and I'll have cosine. Okay? Now, we could have also written this as 1 plus cotangent squared alpha. Cotangent equals cosecant squared alpha. If you wrote cotangent, this is the one where I'd replace the cotangent with the flipped one. So this one would be our 1 plus negative 4 over 7 squared equals cosecant squared. When you solve this one, you'll have cosecant, you flip it, and you have sine.
Okay, so that one's tan, so you have to make it negative 7 over 4. Okay.
Yep.
Okay.
So here's some good advice for you on these. Whenever you write this and you write the reciprocal, write the two equations that get you both of these. So I write the one that uses tangent, and I write the one that uses cotangent, and it'll get you all the rest of them. On the test, like the quiz, more than likely I would just ask for you to find, maybe on this one I would just ask you to find the sign. But if you find the rest of them, you get extra credit. And it really isn't that hard that if you can get cosine or secant, you can get the other one as well.
Yeah.
Okay, so on a problem like this, I would just go ahead and say, okay, tangent, I'm going to write 1 plus tangent squared equals secant squared. Oh, cotangent, I'll write that one as well, and that way I can get all of my trig stuff from there. Yeah. Yeah. Is that far enough, you think?
Yeah, that's good, because then you just multiply the numerator denominator by the squared.
Yep. And then you just add 1 to it, and then you take the square root of both sides.
Okay.
Yep. All right, other questions? I think I have that worked out on here as well. Let me just double check. Yes, I do have all of the steps on here as well. So on the answer key, I walk you through every step after that as well.
Okay.
Okay? As long as this one step makes sense, the rest is easy.
Yeah.
This is actually most of the points.
Oh.
So if I'm doing something, these are most of the point because the rest is just algebra. Okay. This is our big trig part, that we understand that to get from tangent to something else, I have to use the Pythagorean identities. All right, other questions? Guarantee that'll be on the test, though. Yes? Number 3. Three says cosine of 2x. We'll have another way to do this today. But if I said you had to use angle addition or subtraction, I don't have an angle addition or subtraction. I actually have a multiplication. But remember, multiplication is just repeated addition. You need to realize that cosine of 2x can also be written as cosine of x plus x, which would be one of our identities, where you have an angle plus an angle. So if you take out your sheet, remember these will all be given to you. This is you just looking at it. Well, cosine of an angle plus an angle equals cosine sine minus sine cosine. This little sheet? Do you have this little sheet? Okay. Do you see where I'm pulling that from then?
Yes.
Okay, I'm sorry, cosine, cosine. So this would be cosine of our first angle. Our first angle is x. Cosine of our second angle, which is also x, minus sine of the first angle, which is x, times sine of the second angle, which is x, which is just cosine squared minus sine squared. You'd be done after this step. So we would just go, okay, this would be cosine squared x minus sine squared x. Put some equal signs. That does equal the other side. I am good. Okay? All right, other questions? Well, this leads us into actually new information where we have the rest of this white little sheet will be provided for us. Remember, the back side will be provided for you. The front side needs to be memorized. So the front side has like your sine, cosine, tangent, cosecant, and your identities. The back side, I'm talking about our sum and difference, double angle, half angle. Those will all be provided for you. But if you look at this sheet and you look at your double angle identities, in fact, look at your first one. It says cosine of 2x just straight up equals cosine squared minus sine squared. So we don't have to do this work anymore. We could just say, okay, if I have 2 times something, that's called the double angle formula. So if we can ever write it as 2 times something, if it's sine of 2 times something, we could say that equals 2 times sine of the angle times cosine of the angle. That gets rid of the 2. Because the 2 doesn't help me, but I can break it apart into something that will be on the unit circle. Same thing for cosine. Now the cosine is weird because there are 3 different ways to write it. So cosine is the weird one because there's 3 different ways, and these are all correct. Most of the time with cosine, you just get pick which one makes sense to you, which one's easier for you. These would just be find the cosine value, square it, minus the sine value, square it. The nice thing about the other ones, you just have to find one value, but you do have to do the one minus. For me, I usually do the cosine squared minus sine squared, but a lot of times it'll just be up to you on which one you want to use. And finally, tangent would equal that. Once again, the only scary thing is memorizing these, but you don't need to memorize these. These will be provided for you. You just have to know when to use them. Now, just like multiplication, you can also divide an angle, which creates 3 new identities. If I have sine of a number divided by 2, I can rewrite it as this. These are the more complicated ones. Once again, they'd be hard to memorize, but you don't have to memorize them. You just have to look at, am I supposed to use a half angle? Oh, I need to put in this form and rewrite it as this. Same thing with cosine. Cosine of a number over 2 equals plus or minus the square root of 1 plus cosine x over 2. These can be confused between each other because one just has a negative and one has a positive. Once again, these will not have to be memorized. They'll be given to you. Take a second and make sure you understand where you're using a plus and where you're using a minus. Finally, tangent has 3 different half-angle formulas. I have one bolded. If you have a choice, use this one. If you have a choice like we'll have today, use this one.
Wait, for what?
When we're using these half angles. We'll see when we get to the problems.
Okay.
I'm going to say when you see tangent of half angle, use this one. Because this one creates square roots that we have to get rid of. This one, we have to do addition of fractions. So let's say cosine equals square root of 2 over 2. We have to push these together, keep, change, flip. This one will just be easy to keep, change, flip. So if you have the choice, use this one. I'd box that one in. Yeah?
This is an irrelevant question, but is there a reason why sine uses negative and cosine uses positive for those identities?
Yes.
Okay. Does it really matter?
We're not going to go through that. We just don't have time. But
Okay.
it kind of goes back to, remember in double angle formulas?
Okay.
The double angle formulas where we had, angle addition and subtraction formulas. In fact, let's just look at that real quick. It's not going to take that much time. I'll just give you the basic gist of where this comes from. So the question is, why does sine have a negative and cosine has a positive on these? And these really break from when we did our angle sum and differences. When I had cosine of a sum, we used the subtraction sign. When I had a sine of a sum, it became a positive sign. So they're always going to be alternate positive and negatives in there. But that's a very, very short answer for what could be a more complex question. Okay, so on the test, I will specifically say what I want from you. That way you're not like digging around for particular things. So I'll say something like, use the double angle formula to solve this. Now, here's the hard part. Is sine of 120 degrees on your unit circle? Yes, it is. So for this problem, the answer is not going to get you points because that's already on the unit circle. It will say you have to use the double angle formula to solve this, which means you need to create something that says sine of 2 times something. So as soon as I see the word double angle identity, I'm going to immediately write down, oh, that's 2 times something. I need to rewrite 120 as 2 times something to make it a double angle. 2 times what equals 120? 60. So the big part about this is the 60 degrees. This is the angle I'm going to work with. This is kind of my alpha, or just the angle I'm working with. This is breaking apart 120 into 2 times something. Well, once we have that something, we just have to go back up to our double angle identities. So our double angle identity says, for sine, it's just 2 times sine of that angle times cosine of that angle. So we go back here and we go, okay, I'm going to rewrite this as 2 times sine of that angle times cosine of that angle.
Where is it on? Oh.
Yep, it's on there. It's in our notes too right now. Yes, but it would just be in that double angle right in the center. I guess I could have went right there. I guess I don't have a good picture of it. Let me take a picture of the one that we have. And I'll tell you right now, the one on the test is going to look similar to this. So I don't want to throw anyone off. So the one I provide you on the test will look similar to this. Where we can go, double angles, those are all in the middle. And we have sine of 2x equals 2 sine x cosine x. So I have 2 times sine of 60 times cosine of 60. So we'll have 2 times, what's the sine of 60 degrees? It's been a while, huh? Square root of 3 over 2? You can write the unit circle if you want to on the test. And that means the cosine of 160 must be 1 over 2.
So yeah, you're not gonna, we can't have the yellow sheet with us. We're gonna have to.
We pretty much needed to know it for the whole year so far, right?
Yeah.
We should probably know the unit circle by now, especially that first quadrant. What's 2 times 1/2? Two times 1/2 is just 1, right? So we're just left with square root of 3 over 2. What's the sine of 120 if you look at your unit circle?
Square root of 3 over 2.
So we get the right answer. But the answer is not the important part here. It's that you can use the double angle formula. So don't go, 120 is in the unit circle, I have the answer. You don't get points for that. You need to use the double angle formula. Okay, so we know our answer should be square root of 3 over 2, but this one says use the half angle identity. It says use the half angle identity. Half angle means I need to rewrite this. 120 is something divided by 2. 240, yes. So we're going to write this as 240 degrees, because 240 divided by 2 is 120. So this is the angle I'd use for the half angle formula. So I'm going to use 240. So now we look at our sheet that we provided for us. We find our half angle formula for sine. Well, sine equals x over 2 equals plus or minus the square root of 1 minus cosine over 2. So we're just copying that down. So this will equal plus or minus the square root of 1 minus cosine of 240. Divided by 2. We have to figure out whether it's positive or negative first. This is how we're going to figure out if it's positive or negative first. What angle is what quadrant is 120 in? Second quadrant.
So then if you go...
So this is... Don't worry about the half angle or the double angle. You're just worried about this being quadrant 2. What's positive in quadrant 2? All sine is positive. So in quadrant 2, sine is positive. So we're going to snag the positive one.
Even if we're doing 240?
Even if you're doing 240, because we're looking for the sine of 120. We're using another angle, kind of like, remember reference angles? Where we'd use like a reference angle, put everything in quadrant 1, but we had to remember if it's positive or negative. We're basically using 240 as a different way to get to this 120. Okay, so now we know that we're going to use the positive. Now we need to know the cosine of 240.
That's negative 1 over 2. Yeah.
Negative 1/2. Now this is why we just have to worry about the positive and negative out front, because this negative will never come out front, because this is underneath the square root. That is under a square root. I'm going to do my trick because it works better for these problems. My trick is not to push these together and do keep, change, flip. Instead, what I'm going to do is I'm going to get rid of this denominator by multiplying the entire numerator by 2. So I'm going to go ahead and I'm going to multiply the entire numerator by 2, which means I'm going to multiply the entire denominator by 2 as well. So that 2 is going to go to both those things. We're going to have a positive square root of 1 times 2 is 2. What's a negative negative? See how we have a minus and negative? It should turn into a positive. What's 2 times 1/2? 1. 2 times 2 is 4. 3 over 4. Well, square root of 3 over 4. Square root of 3 is just square root of 3. Square root of 4 is 2. We end up back at square root of 3 over 2. So the answer is not the most important part of these. These are really just testing, can I give you a more complex formula and you can solve it? Because when you get to more advanced maths, and when we get to some problems like this, you can't actually use regular angles to solve it. Yeah?
How do you get from square root of 3 over 4 to square root of 3 over 3?
What's the square root of 3? Is it a nice and even number?
No.
So I'll just leave it as square root of 3. What's the square root of 4?
2.
2. So realistically, what I'm...
The whole thing.
Yeah, the whole, if the whole thing is being square rooted, it's really square root of 3 over square root of 4.
All right.
I'm giving you these formulas. So I'm doing like the hard work from you. You don't have to memorize them. Your job is just to understand, if I ask for a half angle, how do I set it up? If I'm asking for a double angle, how do I set it up? That's what these are really testing you. Not so much your knowledge of the unit circle. It's just, can I give you a complex formula and you can rewrite something to fit that situation? This is just problem solving. All right. So now we keep problem solving. But it gets a little more complicated when I give you radians. Degrees were easy, because degrees are just, 2 times what equals 120? Well, that's 60. Radians become a little more difficult. This is how I kind of picture this, though. We're pulling out a 2. We're pulling out a 2. We're factoring out a 2. Kind of like if I factor a 2 out of 120, if I divide 120 by 2, I get 60. What happens if I take pi over 3 divided by 2? You're going to get pi over 6. Because I already said, I've said this a million times, instead of dividing by 2, think about multiplying by 1/2. So we are dividing by 2, so pi over 3 divided by 2 is pi over 6. Pi over 6 is correct in here. And if you kind of picture this, this is actually 2 pi over 6, which becomes pi over 3, which we wanted. So to get from here to here, it really is just pi over 3 divided by 2, or times 1/2, whatever makes more sense to you. We're factoring out a 2. That means this pi over 6 is my new. All right, so we're using double angles. So we go to our double angles of our sheet. Cosine is the weird one. There are 3 of them. All of them will get you the exact same answer. Can someone help me pick one of the 3? It really doesn't matter. Third one? What's the third one? Just 1 minus 2 sine squared pi over 6. If you want to, try a different one. You should get the exact same answer we are going to get out. All right, so the first thing I need to do is I need to find the sine of pi over 6. So we're going to have 1 minus 2 times, what's the sine of pi over 6? It is 1/2. Pi over 3 would be square root of 3 over 2. Yeah, okay, so we have 1/2 squared. Now we'll do PEMDAS. PEMDAS says we should do the square first, then the multiplication, then the subtraction. All the big powers first and then the weaker ones. So square is our strongest one, so we're going to square it. So we're going to have 1 minus 2 times 1/2 squared is really 1 squared over 2 squared, or 1/2 times 1/2, which is 1/4. Now 2 times 1/4, so we have 1 minus, well that's technically 2 over 4. 2 over 4 is just 1/2, right?
How'd you go from, how'd you get 1/4?
I got 1/4 because I squared the 1/2. So that square came from here. So we were supposed to do sine of this squared. So sine of pi over 6 is 1/2. 1/2 squared is 1 over 4. 2 times 1/4 is 2 over 4, or 1/2. 1 minus 1/2, what's 1 minus 1/2? It's going to be 1/2. Is the cosine of pi over 3 equal to 1/2?
Yep.
So this provides us kind of a nice way to be able to check our answer. However, then we step it up a little bit more. Pi over 8. Is pi over 8 on our unit circle? No. So on this one, we would have to use either addition or subtraction. We learned that the week before. We could change this to 2 angles being added or subtracted to pi over 8. Or now we can turn it into a division, a half angle formula. Now, to figure out what goes in here, I factored out a 2. For this, we're kind of factoring out a 1/2. Now, like I said, this is where it gets a little bit more dicey, because it was pretty easy with 120. We just doubled it and we got 240, and then we take a half. So we're going to do the same thing. We are going to double this, so when I divide by 2, I get the same thing out. So to get from here to here, we are going to double this. We'll do 2 times pi over 8. And here's where it's confusing because it seems like I'm doubling it and it's a double angle.
So it's
Well, we're doubling it so we can figure out what goes here so I can use the half angle. So that's where it gets confusing. I don't want that to be there. Give me 1 second. All right, so we have 2 times pi over 8, which would be 2 pi over 8, which would just be pi over 4. And pi over 4 divided by 2 gets me back up to pi over 8. That is correct. So pi over 4 divided by 2 gets me back up to that pi over 8. All right, but that means the angle I'm using is pi over 4. Is pi over 4 on a unit circle? Yeah. All right, let's pick another one of these to use. Not this one. What other one can we use? Oh, no, half angle only has one. Yeah. For some reason, I thought we were double angling it again. No, we're using half angle. So if we go to our sheet, our half angle for cosine only has 1, and that's going to be the one that has the plus cosine in it. So we're going to have plus or minus the square root of 1 plus cosine of pi over 4 divided by 2. What quadrant is pi over 8 in? I know we might not know it because it's not on our unit circle, but is it less than pi over 2?
1.
Yeah, so we're in quadrant 1. Is cosine positive or negative in quadrant 1? It's positive. Everything's positive in quadrant 1. This right here is quadrant 1. And so you'd use the positive. Now the rest is just algebra. So we're going to have equals a positive square root of 1 plus square root of 2 over 2 over 2. Now you could add this with the fractions. You could do keep, change, flip, and you can solve in here. I find it easier to multiply the top and bottom by 2. It's one of the easier ways to get rid of fractions, so we don't have to do that keep, change, flip, and push fractions together. So I'm going to multiply the top by 2. I'm going to multiply the bottom by 2, making sure that 2 gets distributed to everything. So that's now going to give me a positive. 2 times 1 is 2, plus square root of 2 all over 4. Does anyone off the top of their head know what the square root of 2 plus square root of 2 is? Yeah, excuse me is a good reason. We do not do anything with the top. We leave that as square root of 2 plus square root of 2. What's the square root of 4? 2, and that's as far as it goes.
I was just wondering where that first square root of 2
Where it came from? It came from the cosine of pi over 4. Because the cosine of pi over 4 was square root of 2 over 2.
You said it was like it's square root of 2 plus square root of 2. I know where this one came from. I was just confused by that.
There isn't a second one.
Oh.
So when you multiplied by 2, we would have 2 here,
Mm-hmm.
and these 2's would cancel out. This would just be a square root of 2 right here.
Right.
Oh, that's all you have?
Yeah.
Yeah, well, you're good.
Oh, all right.
You have everything you need.
All right.
Yep. Because you have this square root of 2 on your sheet, I see. You just crossed it out. So just one more step because we can do the square root of 4. Can't do the square root of the top. Yes?
Oh, when you multiply the square root of 2 over 2 by 2, how'd you get the square root of 2?
Because all that does is it clears the fraction. So if I had 2 times the square root of 2 over 2, that's really just 2 square root of 2 over 2. And the 2's just turn to 1.
Okay.
And you're just left with the square root of 2. So the whole goal is, if you see a denominator in a fraction, we can always clear that fraction by multiplying by the denominator.
Was that the objective?
That's the goal.
Okay.
That's the goal, so I didn't use keep, change, flip, because to use keep, change, flip, I'd have to push these fractions together and then do keep, change, flip, where this one is, hey, if I just want to get rid of that fraction, I can multiply by the denominator. That was my goal, just get rid of that denominator, get rid of that fraction. And then I hope everything works out. Okay, sometimes it works. Other times we have to still do keep, change, flip. Okay? Other questions on that one? Okay, then we switch to tangent. it says the same thing I just wrote there. It says use double angle identity and use the half angle identity. So this time we have to do a little work here. So to use the double angle, we have to have tangent of 2 times something. 2 times something. So I would get in the habit of doing that. Double angle means 2 times something. Half angle means I should have something divided by 2. So this one's going to be tangent of something divided by 2. Kind of like angle sum and subtraction. Angle sum and subtraction, I'm looking for 2 angles being added or subtracted. For this one, I'm looking for an angle multiplied by 2 that equals this. For this one, I'm looking for an angle divided by 2, which would equal that. The nice thing about this one is that 2 is already attached through multiplication. This actually is already a double angle formula just in disguise. Because this is 2 times pi over 3. Because remember, to get from here to here, I'm actually factoring, I'm pulling out a 2, so I'm dividing by 2. So this really is 2 pi over 3 divided by 2, or multiplying by 1/2. Whatever makes it easier for you. For this one, though, we actually double it to put in there so I can divide by 2. So to get from here to here, I'm actually taking that 3 pi over 8. I'm multiplying by 2, which would then equal 3 pi over 4. Because 3 pi over 4 divided by 2 is 3 pi over 8. So we really only have 2 hard things that you need to do. You need to understand what's going here and what numbers go there. The rest is just plugging into an equation that I'll give you. So the rest is just plugging stuff in. So this says find the double angle formula for tangent. So you go to your sheet and you find your double angle for tangent. Tangent just has one of them. It's 2 times tangent x over 1 minus tangent squared. So this one's just going to equal 2 tangent pi over 3 all over 1 minus tangent squared pi over 3. That means I probably need to know what the tangent of pi over 3 is, huh? What's the tangent of pi over 3? What was that? I don't know. Is that a question?
No, I think that's
It is it?
Yeah.
Okay, so it's just square root of 3. What's the tangent of pi over 6?
No, it's square root of 3.
It's square root of 3 over 3. Remember, we need to know our quadrant 1 values at the minimum. All right, so that's just square root of 3 for all of those tangent values. So we're going to have 2 times square root of 3 all over 1 minus square root of 3 squared. There's not much we can do with the top, so we'll leave that as just 2 times square root of 3. The bottom, though, we'll have 1 minus square root of 3 squared. Is that 9? Because square root of 3 times square root of 3 is 9?
3.
Oh, it's just 3. Oh, square root of 3 times square root of 3 is just 3. 3 times 3 would be 9, but square root of 3 squared is just 3. Keep going. We'll have 2 square root of 3. That's a negative 2. So this should equal a negative square root of 3. And I bet you if we looked up the tangent of 2 pi over 3 on a unit circle, we would have negative square root of 3. All right? We just have one more to do. So that means we covered every one of our half angle and double angles. I gave you at least one example of each one. Now our next one says tangent of a half angle. Then we go to our sheet. You already lost my sheet. But if you go to your sheet And you see that tangent has 3 of them. I told you should have one of them boxed in. At the very least, I highlighted one. I said, if you have a choice, use the middle one. Why would I use the first one when there's a giant square root in there? That means I'm creating a whole bunch of square roots I need to get rid of. The bottom one is going to create fractions in the denominator that I have to add to 1, and keep change flip doesn't quite work as well. So my advice is use the middle one. It's easier. At least use the last one. Either the middle one or the last one. Don't use the first one. Yes?
How do you know if you have a choice?
We're going to be doing verifying with these. So tomorrow there might be one that has square roots on the other side, and we're like, oh, I got to use the one with square roots.
Okay.
So when we're verifying things, it forces you to use ones that you don't want to. But for today's lesson, we can always use one of these two because it's on me. It's on me to decide which one of these to use. I just have to use a half-angle identity. Okay? So the question was, when do we have to use one of the other ones? It might be when we have to verify them. Okay, so let's use the middle one because that's the one I have highlighted. The middle one says just do 1 minus cosine of 3 pi over 4. And that's going to be just divided by our sine of 3 pi over 4. Now I know if it's over 4, it's square root of 2 over 2. That I know. What quadrant is 3 pi over 4 if it's 1 less?
2.
We're in quadrant 2. All students' sine is positive. Cosine is negative. So we should have 1 minus a negative square root of 2 over 2 all over a positive square root of 2 over 2. Now we could use keep, change, flip. I could just keep the top one, flip the bottom one, change it to multiplication. What else could I do to clear those fractions? Multiply by 2. And it turns out if I multiply the top by 2 and the bottom by 2, I clear all of my fractions. Especially if we have the same denominator in the top and bottom, it usually means it's probably easier to multiply by 2. So I'm going to go ahead and I'm going to use that to clear my fractions. Multiply the top by 2, multiply the bottom by 2. Just don't forget that 2 gets distributed to everything. So basically the 2 goes to everything. If that helps you, so you don't have to write that 2 over 2. 2 goes to everything in that fraction. So that 1 gets multiplied by 2. So we have 2. I have plus square root of 2. And then on the bottom, we clear that out, and we have a square root of 2. What should I do? It probably wouldn't be such a big thing on the test. Maybe I'd take a half point off because you didn't try it at least. But we should try to clear that square root. So we should at least attempt that so we can at least get most of our points. So I'm going to go ahead and I'm going to say it's not the biggest part of this, but I should do this. Bless you. I'm multiplying everything by square root of 2, which will give me, when I distribute this everything by square root of 2, we'll have 2 square root of 2. Square root of 2 times square root of 2 is just 2 over 2. Our numerator has an addition sign, so we can break it apart into 2 fractions. We can break this apart into 2 square root of 2 over 2 plus 2 over 2. I'm also very happy if you just do, this is what I typically do. I just draw an arrow saying it goes to both things. This shows me it's splitting apart, but you could just draw the whole thing being split apart. Whatever is easier for you to remember. 2 squared root of 2 divided by 2, that's just square root of 2 plus 1. Good. If this was me, I'd probably move the 1 to the front to make it 1 plus square root of 2, but I have terrible penmanship, so that 1 gets lost underneath that square root. If you put it in front, it doesn't happen, but square root of 2 plus 1 is the great answer.